This is a simple explanation of climate change, based on an article in the New York Times. The average temperature on the surface of the planet has already increased 1.7 degrees Fahrenheit since 1880, which may not seem like much, but think about it this way. The heat from human emissions is roughly equal to 400,000 Hiroshima atomic bombs exploding across the planet every single day. Future generations are in big trouble, but for now, it'll gradually continue to get warmer and storms will grow more intense, with longer periods of drought in between. But longer term, if emissions continue to rise unchecked, the climate disasters will be so severe they will destabilize entire nations, send millions of refugees across borders, cause widespread extinction of most species on Earth, and melt the polar ice caps, leaving most of the world's coastal cities several feet underwater. All this could take centuries, but something like the sudden collapse of agriculture would trigger immediate chaos in society. Best case is we get our act together and begin to rapidly bring emission levels down. Meanwhile, Earth turns out to be less sensitive to greenhouse gases than we currently believe, plants and animals adapt quickly, and major technological breakthroughs help society limit emissions and adjust to climate change. But these are all the opposite of what we're actually seeing, so the only thing in our control is to limit emissions using all available tools and best behaviors currently at our disposal. Worst case, the collapse of food production causes spiraling prices, and as our capitalist utopia breaks down, billions starve as our world gets violent and messy real quick, kind of like a zombie apocalypse, but with extreme hunger spreading chaos instead, so yeah, still just like a zombie apocalypse. This would be coupled with the melting of the Antarctic ice sheet, leading to rapidly rising seas that would force us to abandon many of our greatest cities and all of the social and scientific progress that we were making within them. Adding insult to injury is the fact that many of the emissions were emitted while building these now abandoned underwater metropolises. If emissions continue unchecked, we're looking at a total rise of between 80 to 160 feet, which would occur if all the ice in the poles melted. So the oceans will rise. The real question is how fast. Scientists only have Earth's history to base their predictions on, which suggests that the rate has occasionally hit 1 foot per decade, so we'll have to adapt to an altered coastline sooner or later, but probably much sooner than later, because computer forecasts only give us a range of future possibilities. The most important evidence comes from the study of past climate conditions, which clearly show that every time the amount of carbon dioxide in the air rises, the Earth warms up, ice melts, and the ocean rises. What's important to remember here is that we are in uncharted territory. Humans are pumping carbon dioxide into the air far faster than nature ever has before us. Scientists have been publishing strong evidence that warming is making drought and heat waves more frequent, causing heavier rainstorms and more severe coastal flooding. But while the internet has made us all more aware of weather disasters in distant countries, it's hard to prove these are all directly made worse by climate change. Canada and Russia both have vast frozen lands and could see some economic benefits from a warmer climate. Putin and the Russians, and until recently Canada as well, have been reluctant to make ambitious climate commitments, but expect that to change as these countries realize they will be swamped by millions of refugees from less fortunate nations. Libertarians and other political conservatives do not like the policies proposed to fight climate change, and have chosen to try and block them by actively undermining the science. This effort has been funded by the oil and coal industry, who favor making money above all else. As more resources are devoted to solving the problem, our chances at big technological breakthroughs are improving, but we still should be spending about 3 times as much money as we currently are on these efforts, according to several in-depth reports. You can reduce your carbon footprint by doing things like plugging leaks in your home insulation, installing a smart thermostat, taking public transit, taking less airplane trips, buying an electric car, and putting solar panels on your roof. A big one is eating less meat. But what's really needed is for you to speak up and exercise your rights as a citizen, because strong collective action through state and national policies is how we'll make the most impact.
We hear it so much that it feels like a buzzword, but it is far from it. Climate change is a real and serious issue. But isn't the climate always changing? What exactly is climate change, and why should we care? Well, the Earth's climate has changed throughout history. Most of these slight changes are caused by small variations in the Earth's orbit. But climate change as we know it today is characterized by an abrupt increase in the Earth's temperature. It is estimated to have gotten 1.2 to 1.4 degrees Fahrenheit warmer in just the last century. 10 out of the last 13 years were the warmest on record. 97% of climate scientists agree that this new tendency is not caused by the variations of the Earth's orbit, but rather very likely caused by human activities. That means you and me. And since the Industrial Revolution, we have come a long way. Humans built airplanes, faster cars, developed remarkable technology, and learned how the natural resources around us can be used for our benefit. Although this has led to many wonderful inventions and advancements, like the device you're using to watch this video, or the ability to take a plane halfway around the world, it also means we've increased our consumption of natural resources and in turn released a lot of greenhouse gases into the atmosphere. Now, greenhouse gases occur naturally, but in excess can be dangerous to our planet. Modern human activities have increased the release of non-naturally occurring greenhouse gases because we have stepped up our demand for burning fossil fuels. The composition of greenhouse gases traps heat radiated from the sun. The more heat they trap, the warmer our planet gets. And as our planet gets warmer, we begin to feel the effects. One of climate change's biggest victims is our oceans. Oceans regulate the Earth's temperature and provide 50% of the Earth's oxygen. Now, climate change has increased the global temperature of the oceans by more than 0.3 degrees Fahrenheit since 1969. Although a warmer ocean might seem inviting to a beachgoer, it actually has devastating consequences for supporting life at sea. One of those consequences is ocean acidification, a direct effect of increased dissolved CO2. Since the late 18th century, ocean surface acidification has increased by 30%. A higher acid content means calcifying species, like oysters and clams and shallow water corals, are at risk, putting the entire ocean food web at risk. This is bad news for the 1 billion people relying on the ocean as its primary source of protein. Climate change has also caused the sea level to rise. Just in the last century, sea levels have risen 6.7 inches, but the rate in the last decade has nearly doubled. Sea levels have risen because as the ocean gets warmer, it swells. On top of that, glaciers and ice sheets are melting. Antarctica lost 36 cubic miles of ice between 2002 and 2005, and since 1994, each year on average, the Earth has lost 400 billion tons from its glaciers. That's like an ice cube 7.5 kilometers on a side, 4 miles on a side, melting and flowing into the sea. When all that ice melts, it fills up our oceans, and just like filling up a bathtub, the shores can't hold all that water, and coastal regions get flooded. Troubling signs of climate change are increased extreme weather events. Natural disasters like floods, tornadoes, and deadly heat waves are more obvious to humans because of their immediate impact and their sharing of the images in the media. Climate change, as we know it today, is change in our Earth's overall temperature with massive and permanent ramifications. Although its consequences can be planet-threatening, scientists still believe there are things we can do on a personal level to help. Recycle and reuse things. Walk or use public transportation to get to work. Turn off your electronics when you're not using them. Eat less meat. While you're at it, eat more locally grown vegetables and foods. And last but not least, spread your knowledge and concerns about climate change with others. When it comes to climate change, the main takeaway is that it's real. And although we are part of the cause, we can also be part of the solution.
35 kilometers above Earth's surface, a gas called ozone surrounds the planet. The ozone layer acts as a barrier between Earth and ultraviolet radiation from the sun. However, pollution has caused the ozone layer to thin, exposing life on Earth to dangerous radiation. Earth's atmosphere is made up of 6 layers. The second layer, called the stratosphere, contains the ozone layer. The ozone layer is made up of a highly reactive molecule called ozone, which contains 3 oxygen atoms. Ozone is a trace gas in the atmosphere. There are only about 3 molecules for every 10 million molecules of air. But it does a very important job. The ozone layer acts as Earth's sunscreen, absorbing about 98% of damaging ultraviolet or UV light. But the ozone layer has gotten thinner. Chemicals called chlorofluorocarbons, or CFCs, are the primary culprits in ozone layer breakdown. A CFC is a molecule that contains the elements carbon, chlorine, and fluorine. CFCs are mostly found in refrigerants, aerosols, and plastic products. When CFCs are exposed to ultraviolet rays in the atmosphere, they break down into substances that include chlorine. The chlorine reacts with the oxygen atoms in ozone and rips apart the ozone molecule. Areas of damage in the ozone layer are often called ozone holes, but that name is misleading. Ozone layer damage is more like a thin patch, with the thinnest areas near the poles. The ozone layer above the Antarctic, in particular, has been impacted by pollution since the mid-1980s. There, the region's low temperatures speed up the conversion of CFCs to ozone-damaging chlorine. About 90% of CFCs currently in the atmosphere were emitted by industrialized countries in the Northern Hemisphere. In 1989, the Montreal Protocol banned the production of ozone-depleting substances. Since then, the amount of chlorine and other ozone-depleting elements in the atmosphere have been falling. Scientists estimate that chlorine levels will return to their natural state in about 50 years. By then, the Antarctic ozone hole will shrink to smaller than 8 million square miles.